This lesson is area and perimeter of rhombi and trapezoids. We want to be able to both find the perimeter and area of a rhombus given the side lengths or the length of the diagonal. And we will calculate both the perimeter and area of trapezoids given the side lengths or the altitude. Okay, so here first we're looking at a rhombus. The definition is all the sides are the same, but also there's some other properties that hopefully you remember, and one of the most important ones is that these are all right angles, okay? But the formula for area is you just take the length of one diagonal, so diagonal 1, and you're going to multiply it by the length of the other diagonal, diagonal 2, and divide by 2. And the perimeter is you just add up all the sides, and since they're all the same, we can just say 4 times whatever the side length is. Okay, so now let's look at some examples. In this first one, again, recognize that we have right angles here. Okay, that those are all right angles. And so we have 4 congruent triangles there. Well, to find the first diagonal, it's just this here, which is 6. To find the second diagonal, this one here, 4 plus 4 is 8. So the area is simply 8 times 6 divided by 2, which is 24. But now to find the side length, we need to use Pythagorean theorem, or hopefully you'll recognize that this is a Pythagorean triple and it's 3, 4, 5. If not, you can always do 3 squared plus 4 squared is equal to c squared, and you will get 5. And now since the side is 5, and since all the sides are the same as the definition of a rhombus, 5 times 4 is 20. So there's our first example. All right, so you should pause the quick check here and try and do this one yourself. Hopefully you did. All right, so we have one diagonal is 24 plus 24 is 48. The other diagonal is not given to us. However, we have our right triangle, okay? And so we can do a squared plus b squared is equal to c squared. This is, I believe, another triple, but I'm just going to call this x, and I'll say x squared plus 24 squared is equal to 25 squared. So I get x squared plus 24 squared. Let's see. I think that is 576. And then 25 squared is 625. And if you take 625 and subtract 576, you get 49. So x squared is equal to 49. X is the square root of 49, which is 7. So this is 7, and of course this is 7 because these bisect. So 14. So the area is 48 times 14 divided by 2. 336. And then the side length was given to be 25, and there are 4 of them, so the perimeter is 100. All right, so here, draw and label the rhombus described, then record. So here they don't give us a picture, and don't worry so much if your pictures aren't perfect, because my pictures are never very perfect. Okay, something like that. That looks more like a kite, but let's pretend that all the sides are the same. And one has a diagonal of 10 and the other 20. So let's see. We'll make the long one 20, and of course I could say 10 and 10 because we know this is a bisector. And if the other one is 10, this would be 5 and 5. Okay? So to find the area, it is the diagonal 20 times the diagonal 10 divided by 2. So that is 100. I have one, now I need the side length. So here, these are right angles. And yeah, I don't really see a relationship. I think it's going to have to be Pythagorean theorem. 5 squared plus 10 squared is equal to c squared. So I get 25 plus 100 is equal to c squared. So c squared is equal to 125, and so c is the square root of 125. Now I can rewrite that as 25 times 5, and so that's the square root of 25 times the square root of 5, and the square root of 25 is 5, and so the side length is 5 times the square root of 5. And so that's my exact answer. Approximate, we can look it up. The perimeter is 4 times that, so it would be 20 square root of 5. And now if they want the approximate length, just use your calculator. 5 times the square root of 5 is approximately 11.18. And 20 times the square root of 5 is approximately 44.7. Okay, so please try and pause for the next quick check. Okay, find the indicated measures of a rhombus if it has diagonals of 18 and 24. So again, it's always helpful, I think, to kind of draw a picture, even if your picture is not very good. And I have diagonals of 24 and 18. So half of 18 is 9, so 9 and 9, and 24 is going to be 12 and 12. Okay, I can find the area real quickly because it's just diagonal 1 times diagonal 2 divided by 2. So I just use my calculator and I get 216. But now I need this to find the side length because I have a right triangle. This one is a triple, okay? 9 squared plus 12 squared equals c squared. I'm about 99% sure the answer is 15, but let's do it. 81 plus 144, and 144 plus 81 is 225, is equal to c squared, and the square root of 225 is 15. So the perimeter is 4 times 15 are 60. Okay, and the next problems, a lot of the same stuff, but here I see a 30, 60, 90 triangle. So again, you're going to go back and you're going to have to use your special rights. So 30, sorry, excuse me, 30, 60, 90. And you are going to have to know x, 2x, and x to the square root of 3. So in this picture here, I see a 30-degree angle and a cross summit of 3, okay? And remember, in a rhombus, all these angles are the same, okay? So this 3 would be here, and it would also be here. Okay, now for the other angle, these are my 60 angles. So if across from 30 is x, across from 60 is x to the square root of 3. So these are going to be 3 to the square root of 3. Okay, so one diagonal is 6. The other diagonal is 6 times the square root of 3. And the area is diagonal 1 times diagonal 2 divided by 2. So 6 times 6 is 36, divided by 2 is 18. So the area is 18 times the square root of 3. And now a side length, okay, well we have, again, 2x is across from 90, and so if x is 3, this is going to be 6. So those are all 6. So side length is 6, perimeter is 24. For the approximate ones, you just use your calculator. 6 times the square root of 3 is approximately 10.4. And 18 times the square root of 3 is approximately 31.2. okay? But the exact is the one that we really want to focus on. All right, let me scroll down real quick. Okay, see if I can finish the rhombi and then we'll have to pause. All right, 30, 60, 90 triangle. Please pause this one and try it yourself. Okay, I notice a 30, 60, 90 triangle. And dude, they got to give us something. What do they give us? Maybe I missed something here. Must be missing something here because there's no other measurement on here, so there's nothing we could do. But so let's just make one up, I guess. I have no. Let's say that they told us that I'm not sure. Let's say this is 10 to the square root of 3. Okay, so if the side across from 60 is 10 to the square root of 3, that would make this side across from 30 10. X, 2x, and x to the square root of 3, and that would make the sides 20. All right, so there wasn't one for us to do here, but just to kind of practice, and then we could fill in the rest. Let's go on to the next problem. All right, draw and label the rhombus described, and then record the exact and approximate answers to the 10th place. This means you can use your calculator, all right? So the diagonal of a rhombus is 3 times as long as the other one. So I have a rhombus, so kind of just draw it. They don't tell me much, but they tell me that one of the diagonals is 3 times the length of the other. Well, the formula is diagonal 1 times diagonal 2 divided by 2 gives me the area. And so what I know about one of the diagonals is it's 3 times as long as the other. So I'm going to call that one 3 times x, and I'm going to call the other one x. And I know when I divide by 2, they tell me the area is 24. So I can go ahead and multiply in the numerator and get 3x squared. Divided by 2 equals 24. Now let's get rid of this division here by 2 by multiplying both sides. And I get 3x squared equals 48. We'll divide both sides by 3. We get x squared is equal to 16. So x is equal to the square root of 16, which is 4. So x is 4. And we go back here, and one of our diagonals was x, and the other one was 3x. So one of them is 4, and one of them is 3 times 4, or 12. If you want to check your answer, let's try. Diagonal 1 times diagonal 2 divided by 2 should be equal to 24. And yes, it is. Okay, see if you can do the quick check below. And then we're going to pause and start a second video because we're basically almost out of time. So the quick check, find the length of one diagonal of a rhombus. If the area of 15 square centimeters and the length of one diagonal is 5. So area is diagonal 1 times diagonal 2 divided by 2. So you tell us the area is 15. One diagonal is 5, so I'm going to call the other one x. Divide by 2. I'd start by multiplying both sides by 2, and I get 30 is equal to 5x. And then just divide both sides by 5. And x is equal to 6. See if we can do the part B. Find the length of one diagonal if the rhombus has an area of 44. So area equals diagonal 1 times diagonal 2 divided by 2. They tell us the area is 44. It's equal to 11 times x divided by 2. Multiply both sides by 2. Get 88 is equal to 11x. Divide by 11, and x is 8. Okay, just finished that video. I'm going to pause, and then we'll put the second one up. Good luck.